Hello everyone. Basically here's the part 2 of the video from last time because it would be too long. So here's the next question. Please read it. This one. This is a different question. Wait. So read this part. Yep. So let's go. We know that this is the equation. Oops. Let me make this smaller. This is the equation that we would use to find the what's it called? Like time, not the time, but like basically the t. However, we're looking for the force, so we just rearrange the formula. So we get F equals 1/t, and I mean it's actually time. T is time, and we do know the time. It's 0.0. Like yeah. So we do 1.025, and then that equals to the same thing as, oops, no. So let's just demonstrate what it equals to. 5. Yep. Okay, why does it equal to that? So if I go in my calculator and I check what it does equal to 0.025, it does equal to 40. So basically the frequency, oh by the way, yeah, it wasn't the force, it was the frequency. I don't know why I said force. It's going to be 40 hertz, and then we have B, and over here it's very easy. Literally we have the formula. I mean look, like you wouldn't have the formula, but like it would be on, like basically this is the formula. We have the peak voltage and it's square to 155.5 divided by square root 2. That equals to 9.95. So oh hello, connected to, so I can just put it as this basically, and that will be in volts over here. After that we have a wording question over here. However, I don't want to do it, so we're just going to do the next question straight away. So where is it? Is it this one? No, it's this one. Oops. So this is very simple actually. You kind of don't even need a formula for this. It's basically like kind of basic knowledge, if that makes sense. So read the question. Which part exactly? This, yeah, this is the part that you should read. This is another wording question. So yeah, after that, when you read it, we basically use this formula. So it's basically that the question that we did before with the water thing, but here we just do it differently a bit slightly. So over here we asked to calculate the number of turns in the primary coil, I mean, and primary is the like first, like the one, and then if it would be the second one, it would say secondary, I'm pretty sure. So we know that these two that equal, it's also equal as I1, but that doesn't matter right now. We'll talk about that here. So basically, let's just go straight to the point. The way we do it is, again, we move everything around to make what we're looking for the subject. We're looking for the N1. So we need to move the N2 over here, and that will be times. So V1 divided by V2 times N2 equals n1. And if we substitute the numbers in, v1 is 3. Let me just do it because I don't want to. So v1 is 330. v2 is 5, and then n2 is 200. So these all as an answer, when we work it out, it gives us 9,500, and it will be in turns. Over here will be written. So yeah, and after that, calculate the current. So the way we do that is also very simple and pretty easy. So basically, we have the formula for power, which uses current and voltage, and it's the same for both sides, like they're equal, as we found here, they're equal. So we just have to make it the subject, kinda, in a way. So we're looking for I1, so, but we know the I2 and V2, and that's what we need. So basically, look, let's work out the power for this one. So that would be 2 times 5 equals 10 watts, by the way. That's in power. And after that, since they're equal, we can move the V2 here, and that'll be division. So V1, I mean. And so we just divide 10 volts by 230 because that's what it's equal to. V1 is equal to 230, and that's equal to 0.042 amps. And yeah, another word in question, which we're not gonna do. And so next question is this. Yeah. Oops. Okay, there it is. So over here it's very simple. First of all, we're asked to calculate the total capacitance of the circuit. So when it says that, we basically need to not calculate all of it straight away. I mean, that is what total capacitance is. However, it's asking for this part because how can I explain? Well, first of all, to find out the whole thing, you can just do this first and then this. So let's just make this one into one. Just add all these together. All these together equals to 6.22. And after that, we should find. So when they're in what's it called, parallel, we can add them. In series, we do this. It's opposite from the normal circuits, kinda. So after that, we just do this. So we do 1 over 0.47 plus 1 over 1.2 plus 1 over 6.22. This gives us what does it give us? Let me just quickly check on my calculator. By the way, guys, just so you know, I did write, I think I did say that in my first video. However, this YouTube channel is not here for you to learn. I'm learning, but if you're learning, I guess it's a good thing. But if you're like, oh, his explanation is so bad, I mean, that's not the point. The point is for me to understand. I'm talking kind of right now, I'm talking to myself. I'm not trying to help you guys, I'm trying to help myself. So if you don't like my videos, just don't watch them. I mean, why am I saying this? There's literally, I have basically no subscribe. Okay, basically, the answer to this is 2.2, 3.122, and then we have to put 1 over the answer. I can't even spell answer. The answer of here, and this over 1 is going to be, let me just quickly check. 1.3.122. And the answer is 0.320. 0.320. This is the answer to the total capacitance. Yeah. And it will be in microfarads. However, if it asks you to do it in farads, you just divide it by 10 to the power of minus 3 minus 6, because that's what micro is. And then after that we have, this. So this one is also like quite very easy. So basically, please read the question, blah blah blah. So calculate the current flowing in the circuit. We usually think that current equals V divided by R. However, over here this doesn't quite work in the way as we don't have the actual full voltage, because there's a voltage here. Like, there are 2 voltages as we can see. However, we're able to find the second one very easily by just doing 9 take away 0.7, because the voltage drop, that's the drop, like it drops, it like decreases by this number. So the second is 8.3 volts, and then we use this to the Ohm's law over here, 3000, because we convert it from kilo, like we divide it, times it. And then the answer of this is, we could literally just do it. Okay. So this is the answer, and it will be in amps. After that, the reason we use, by the way, the V2, not V1 or V itself, is because V1, it's for the diodes, so that's the diodes of voltage. So the Ohm's law includes the resistor, the voltage, right, and the current, but that's different. We need these two. We can't use this one because this one doesn't have a resistor. We need the resistor in it, and the reason we don't use this one is because we're looking for the voltage here in this area, because that's where the current is drawn, if that makes sense. So first of all, the formula that we will use in this question is this. However, it's not A exactly, because it's the A equals P, which is the pressure, I guess that's what I call it. I'm not sure if it's pressure, length divided by the R, resistance. And we just have to substitute in all the numbers, which is very simple. However, there's this small thing that you should know. So look, usually what you would do, right, like you put in the calculator the 1/6 division. Basically what you would do, I'll just write it like this. You would actually put what's it called, the pressure, and then you times it by the length, and then you divide it by the resistor. Let's just resistor. However, that will give you a quite different answer from the right one. It's not significant as much. However, what I recommend to do is kind of do it separately most of the time. So, for example, basically just do it separately. Do this, then this. Don't do it all together. Okay. And the answer of this, by the way, is 1.34 times 10 to the power of minus 6, and it's in meters squared because it's area.